So the unit that we're looking at here is logic. And out of everything that we do in this class, this is going to be the one that will probably most feel not like a math class. In particular, like, you're not going to use your calculator much, or if at all, and we're not going to do a lot of solving equations. We might see a couple today, but what we want to do is kind of look at the structure of logic and reasoning and how we use it. And instead of taking the point of view like, how can this help us in math, we're sort of going to take a different point of view and say, well, how is this applicable to life? So it's not going to be a really familiar section, because it's not going to be, algebra intensive or anything like that, right? There's not going to be a lot of equations. Okay, but in order to get started with logic and reasoning, we kind of have to figure out what it is we're talking about. Okay, so we want to talk about, what does it mean to reason? What is an argument? Okay, I think oftentimes when we use the word argument in English, we mean sort of like a verbal fight. And that's not really what we're talking about here. Okay, we're going to define specifically what we mean when we say argument, but I think that maybe a better concept to think of when we talk about things like arguments is to think of like in a courtroom when you're arguing a case type of thing. But we'll go to that. In fact, let's go ahead and start with that now. So let's look at some of these initial terms that we're using, and let's define them very specifically so that we're all on the same page. Okay, so let's start by talking about arguments. Okay, so an argument is an organized sequence of statements designed to lay out a line of reasoning. Okay, so to really understand what an argument is, then we need to say, well, what is reasoning? Okay, so reasoning is an organized thought process that's designed. Let's let somebody in. That's designed to find new facts based on known facts. I am recording, yes. Thank you for double checking. I would hate to have to redo this. So we use reasoning a lot in a math class, okay? And there's a name for the specific type of reasoning we use in a math class called mathematical reasoning, because it happens so much, and it's kind of its own separate thing. It's different than a lot of the other reasonings that we'll talk about. Okay. So in mathematical reasoning, we have a set of rules, okay, typically the rules of algebra, that sort of guide our reasoning process, okay? And so what we want to do is we want to learn new facts, usually about numbers, using known facts about the numbers, okay? So here's an example of that. Suppose I want to solve the equation 2x plus 3 equals 7, okay? And maybe you can, look at this and know, okay, the answer is that x equals 2, okay? But the process of reasoning towards that answer, arguing for why that is the answer for x, okay, we could set up an argument like this. We start with our given information, 2x plus 3 equals 7. That was the equation that we were given. So then what I do is I say, okay, I'm going to apply some of my rules of algebra, right? So I'm going to subtract 3 from both sides. Okay, and part of my rules of algebra, or my mathematical reasoning, is that if I subtract a quantity from both sides of an equation, I get an equivalent equation, right? I get another true statement. Okay, so then I end up with this 2x equals 4, and then if I divide both sides by 2, then I can see that x equals 2. So what I've done is not only have I solved that, but I've shown all of the steps in my thinking, and that's what makes this an argument, right? So if you look at an equation and you say x equals 2, that's a statement okay? And it might be a true fact, but this is an argument because I can clearly see all of the reasoning, right? So an argument is an organized sequence of statements. So an argument is not an answer. It's that process of showing how I arrive at my new fact based on my known facts. Okay. All right, let's look at some more definitions. Premises and conclusions. In an argument, we have some facts that we start with as known facts. Those are called premises. And the new facts that we arrive at are called conclusions. Okay. So when we present an argument, we present both the premises and the conclusion. We say, all right, here are the things that we know, and this is what we can conclude based on that. Okay. And it's important to be able to tell the difference, especially when we see written language, right? So like when you're looking at an equation, you could say, okay, the equation I start with is probably the premise, and then the answer or solution, right, is the conclusion. But we want to talk about not just math equations, but we want to talk about seeing arguments written out in English. And when we're writing things in words, things can get a lot more tricky because there's not just one way to do things, okay? There's not one single way to say something that you want to say. There are many ways to say something you want to say. So we want to be aware of that and sort of make sure that we can pick apart all the correct pieces. So here's an example of an argument. And what we're going to do is see if we can identify the premises and conclusions. Okay. All right. So here's our argument. Fozzie is a bear. As a rule, bears are not fuzzy. Therefore, Fozzie is not fuzzy. Okay. So first, we're going to identify the conclusion. Maybe it seems like we're working backwards here, but typically there's one conclusion when we make an argument, so it's easier to find. Okay. The conclusion is a fact that the argument is trying to convince us of, right? Convince us that it's true, okay? So the conclusion here, the thing that we're trying to be convinced of, is that Fozzie is not fuzzy. Oh, I'm sorry. I said fuzzy. That says funny. All right. One of these days I'll learn to read. All right, next we identify the premises. Okay, these are facts that are supposed to lead us to believe that the conclusion is true. Okay, so the statements that we have that, that are supposed to lead us in this direction are that Fozzie is a bear. Okay, and the other statement is that bears are not funny. Okay, and what I want to do here with this argument is sort of look at how it's structured and what is the extra language around that might point out or signify a premise versus a conclusion. Okay, so in this example, right before the conclusion, we can see therefore, right? And that might be a keyword to tell us, okay, this following statement is a conclusion. So the word therefore indicates a conclusion in this example. Okay, so let's see if you got as a class, maybe you can type it in chat or say it loud. What are some other words that you know of that would indicate the same thing, that would sort of indicate that we have a conclusion, right? You have a series of statements and, okay, as a rule, lastly, well, okay, so I want to be careful with as a rule and lastly. As a rule is in this thing, so we're going to talk about that in a minute, okay? Lastly might be a little bit confusing. If I say lastly, that's usually going to be in a list or something like that. And if I have a list of statements, just because something comes last doesn't necessarily mean it's the conclusion. So I don't know. Lastly might be a tricky one here. So, but maybe a very straightforward way, if I want to make sure that everyone knows that what I'm going to say is the conclusion, is I could say something like, we conclude. Okay. Thus works. Yep. That's very common. Accordingly. Okay. So that works. It's really common, very short. I use that a lot when I'm making math arguments because it's, it's very short, easy to write. Okay. This proves. Good. Okay, we could probably come up with more if we sit and think about it, but I think this is a pretty good list, and this gives us a good idea of what we're looking at. So these are going to all be clues, right? Indicators that what we're about to say, or the statement that comes next, is our conclusion. All right, so now let's look at the premises. And when I look at my argument here, Fozzie's a bear. Well, there was no extra language around that. It just kind of sort of jumped right in. But then we have this thing as a rule in front of one of our premises, right? So we're going to use that as our example here. As a rule suggests that that statement is a premise. Okay, so let's come up with some other things that might indicate premises. Now, remember that a premise is something that we are stating as being a known fact, right? So what else could indicate that something is a known fact? Because, good. Since. Due to. Good. Generally. Yeah, I think that'll work. I like to use very direct language. So like up here, my go-to was like, we conclude. That's very obviously a conclusion, right? If I want to say something as a known fact, we could say something like, we know. Okay. Or given. Okay. So that gives us, I think, a pretty good list. So that gives us hopefully a nice set of indicators that, okay, these tell us that something is a premise. Now, one of the things I want you to notice is that when we made our argument, Fozzie is a bear didn't have any other language around it to indicate if it's a premise or conclusion. Okay, so when you make an argument, you're not forced to write all these extra things. These are just, you could think of as clue words, or that they help give you some structure. Okay, but you have to rely a little bit on context. Okay, Fozzie is a bear could be the conclusion of a different argument, right? But we already know what the conclusion is here, so that one's not, right? It's going to be the premise. All right, let's move on and talk about some types of reasoning. We were looking at our very first example with the equation was an example of mathematical reasoning. So let's define that. In mathematical reasoning, the premises are statements about numbers, okay? And we use the rules of algebra to make conclusions, and those conclusions are typically also numbers. Mathematical reasoning is a special type of deductive reasoning. So like the bigger umbrella that we could talk about is this thing called deductive reasoning. Okay, so speaking more generally, in deductive reasoning, the premises include general rules and the conclusion is a special case of the general rules, okay, or parts of the complex statements. So in deductive reasoning, we reason from the general to the specific. Okay. In mathematical reasoning, we sort of take the rules of algebra as being assumed premises, right? We say, okay, if I'm writing something like, 2x plus 3 equals 7, then we're also, without having to say it explicitly, assuming all of the rules of algebra are also known facts, okay? So things like being able to subtract 3 from both sides of the equation to get, another true equation, right? So mathematical reasoning, we just include all of the rules of algebra. Okay, let's look at an example of an argument that uses deductive reasoning that's not mathematical reasoning. It's just generally deductive. So if it rains on Saturday, I do the laundry. This Saturday it rained, therefore I did the laundry. Okay, so we can look at our keywords here. Therefore is, I think, one of the ones that we listed. We didn't list therefore. Oh yeah, I'm sorry, we did. I'm sorry, it's up here. I'm like, I thought we had it. Yeah, it was the example one from our previous example. Okay, same one. So that indicates that we're talking about a conclusion there, right? So our conclusion is, I did the laundry. Okay. So the premises are the other statements. Now, one of these statements is a compound statement. We'll talk about this more in detail later, but it's a statement, if it rains on Saturday, I do the laundry. Okay, so that's one of our premises. Okay. And then the next premise is, this Saturday, it rained. All right. There weren't any extra keywords that indicated that these are premises, but we are just stating these as known facts, okay? And since we did clearly identify the conclusion, that means the other things are going to be our premises, okay? All right. So the first premise is a general rule about what I do on Saturdays, okay? So this is telling you, if it rains on Saturday, I do the laundry, okay? The conclusion is what I do on one specific Saturday. So what I want you to notice is that the premise gives me this general rule, okay, and the conclusion gives me a specific example, okay? So that gives you sort of this idea of, okay, we're talking, we start with these general rules, and then we make an argument about a specific case. That's what deductive reasoning is. Okay. Now let's talk about inductive reasoning. Okay. So the other main kind of reasoning that exists, okay, and that we're also going to talk about is inductive reasoning. Okay, in inductive reasoning, the premises are specific observations, and the conclusion is a general rule that we derive from those statements, or maybe an application of such a rule to cases not observed. Okay, so what we're doing is we're looking at these specific observations, so we're arguing from the specific, okay, to the general. So it's kind of backwards from deductive reasoning, right? Deductive reasoning, we reason from the general to the specific. In inductive reasoning, we reason from the specific to the general. Okay, let me give you an example to help illustrate this. Okay, so I have eaten at this restaurant 3 times. Every time I got sick. Therefore, I will get sick anytime I eat at the restaurant. Okay. All right. So this argument is a general statement. I will get sick anytime I eat at the restaurant, right? That's what we're concluding. Okay, so our conclusion here is that I will get sick anytime I eat at the restaurant. All right, the premises we have are I have eaten at the restaurant 3 times. Okay, the other premise is every time I got sick. Okay, so the goal of the premises here, right, when I say I've eaten there 3 times and every time I got sick, what we're trying to do is establish a pattern. Okay, and the conclusion describes that pattern. So we're trying to establish a pattern which the conclusion describes. Okay, so we look at the specific cases. We look at these 3 times that we ate at the restaurant. Okay, that's our specific cases. And from there, we're trying to describe a general pattern of stuff that happens. Okay. All right, let's look at another example. So this argument is an example of inductive reasoning in which the conclusion is a specific statement. Okay, so here's our argument. For the last 2 days, traffic has been bad on my way to work. Therefore, I expect traffic will be bad on my way to work again today. Okay, so here we're not giving a general rule. Okay, we're making a conclusion about today, right? So I can see my keyword therefore. So my conclusion here is traffic will be bad today. Okay. We only have one premise here. It says for the last 2 days, traffic has been bad. Okay. So in this case, we're still trying to establish a pattern, right? The premise establishes a pattern. But rather than say that traffic will always be bad, our conclusion is just saying that it's going to be bad again today. So the conclusion continues that pattern, right? We say, okay, the last 2 days traffic has been bad. Therefore, I conclude it will be bad one more day, right? So we're just continuing the pattern, one more step. Okay, so the conclusion is an example of a general rule that the argument doesn't state, right? So what goes unsaid here is that traffic will be bad every day. That's kind of what we're arguing, or that's sort of maybe behind the scenes in our reasoning, but we didn't state it. Okay, so the general pattern is that traffic will be bad every day. So that's the general rule, but we didn't have to say that as part of our argument. We could have taken these specific cases and then just argued one more day, because what we're really doing is we're saying, okay, the general pattern is that it will be bad every day, and we're going to apply it to the day that we care about today. All right. Any questions so far? All right. Let's look at some more terms. Okay. Valid deductive arguments. Okay. So when we talk about an argument, not all arguments are the same, right? So we want to sort of break them down, right? You can make some arguments that are just nonsense, okay? And we want to be able to sort of distinguish between arguments that we should believe and arguments that, you know, maybe we shouldn't believe, okay? And that's kind of what we're doing here. We're trying to categorize arguments. So a deductive argument is valid if, knowing that the premises are true, guarantees that the conclusion is also true. Okay, so let's look at some examples. Okay, so here's a valid deductive argument. The first premise, all frogs are green. The second premise, Kermit is a frog. Conclusion, therefore, Kermit is green. All right, so what we're doing is we're saying that if knowing these premises are true, we're guaranteed the conclusion is true. One of the ways to think about an argument is to think about what would it take for the conclusion to be false. So what if Kermit weren't green? Suppose Kermit were blue instead. Okay, how could that be, right? So it might be the case that maybe Kermit is not a frog. Okay. If Kermit is a frog, are all frogs green? Okay. Well, if Kermit is a frog, and Kermit, if we're supposing Kermit were blue, then are all frogs green? Well, no. Kermit is a blue frog. Okay. And in this case, if Kermit were a blue frog, then all frogs are green would not be true, right? And then we can't have both the premises true. Right? So if we think about what it takes to make the conclusion false, in order for the conclusion to be false, I'd have to make one of these premises not true. Okay? And we can't have both the premises true and the conclusion false. So since we can't have both premises true, if the conclusion is false, okay, this argument is valid. Now, when we make an argument, we'll talk about this a little bit more in depth later, but a premise could be false. Okay, so the statement all frogs are green, you might look at that and be like, that's not true, right? There are frogs that are not green. Okay, this could still be a valid argument. To be valid, that means that when the premises are true, that guarantees the conclusion is true. But if one of the premises is false, then it doesn't tell me anything about the conclusion. Okay. All right. So when we make an argument, when we're determining if it's valid or invalid, we don't need to know if we don't need to know all of these facts. We don't need to know about frogs and about Kermit. Okay. What we need to do is say, if we assume those things are true, does that guarantee the conclusion is true? All right, let's look at an invalid argument. Some dogs are gray. Okay, second premise, some dogs are big. Conclusion, all dogs are either big or gray. Okay. And let's just look at an example. Let's suppose that we have 4 dogs in front of us. Okay. Argo is a big gray dog. Chewy is a big brown dog. Bluto is a small gray dog. Dino is a small brown dog. Okay. All right. We do have some big dogs, right? Argo is a big dog. Okay. And Chewy is a big dog. So Argo and Chewy are big. And the second premise is that some dogs are big. So the second premise is true. Okay. Argo is a gray dog. Bluto is a gray dog. Okay, so Argo and Bluto are gray. So that first premise is true. Okay. So my premises are both true, okay, in this situation. So it's possible to have both premises true. However, we have a dog here that is not big, right? Dino is small, and not gray. Dino is brown. Okay. So Dino isn't big or gray, so the conclusion is false. Okay. So we can imagine a world in which the premises are true and the conclusion is false. That means that this is not a valid argument. Okay. So when we want to decide whether a deductive argument is valid, okay, what we do is we try to find a way that the conclusion can be false if the premises are true. In this first one, I could not imagine a way in which the conclusion could be false and the premises true, right? In order for Kermit to not be green, okay, maybe Kermit's not a frog, but that violates a premise. Maybe there are some frogs that are not green, okay, but that makes the other premise false. I can't imagine a way to make the conclusion false and also have the premises true. Okay. And if that can't ever happen, then that's why it's deductive, right? Because if you have true premises, it guarantees that your conclusion will be true. But here, having true premises doesn't guarantee the conclusion is true. Okay. Now, maybe it is true that all dogs are either big or gray in our universe. That doesn't make this a valid argument. Okay. It's not valid and invalid. Don't talk about whether the conclusion is true or false. They're talking about the structure of the argument. Okay. If you have all true premises, are you guaranteed a true conclusion? All right. Now let's look at inductive arguments. Inductive is different when we look at arguing from the specific to the general or looking at specific cases and building a pattern. Sometimes, even if we're reasoning correctly, our pattern is wrong. Okay. For example, if I give you the list of numbers 2, 4, 6, 8, and I say, what's the next number in the list? What do you think it is? So somebody say out loud or type in chat. If I say 2, 4, 6, 8, what's your guess as to the next number? 10, right? I would say that most people would probably say the next number is 10. Because you're looking at that and you're saying, oh, he's probably counting by twos, okay? Not knowing that these are the first 4 digits of somebody's phone number in Michigan. Okay. All right, so maybe you did correct reasoning, but you were still wrong, okay? It's not that your reasoning was terrible. It's just that, okay, sometimes patterns don't actually turn out the way you think they are. Okay, so when we use inductive reasoning, everything is a little bit more tricky. All right, so let's go over what it means for an argument to be valid if it's inductive. An inductive argument is valid if knowing that the premises are true makes the conclusion very likely to be true. Okay. We don't have the same guarantees in inductive reasoning as we do with deductive reasoning. Okay. So this definition is, less precise than the deductive one. Okay. So let's look at an example of a valid inductive argument. I've never seen a purple cat. I've seen a lot of cats. Therefore, I conclude there's no such thing as a purple cat. Okay. So the second premise here, I've seen a lot of cats, that suggests that if there were purple cats, I probably would have seen one. Okay. But maybe not, right? Maybe I've seen an awful lot of cats in the world, but there's one purple cat walking around somewhere that I've never seen. It's possible, okay? And that doesn't sort of ruin our argument, okay? In a deductive argument, if the premises are true, then the conclusion is guaranteed. Okay. And that's because deductive arguments have these general premises that always apply. In an inductive argument, if the premises are true, the conclusion is only probably true. Okay? Because inductive arguments have these specific premises. Okay? And when we look at specific and we form a pattern, sometimes those patterns just don't hold. Okay? Even if we see a pattern and what we're looking at fits the pattern that we described, that might not be the actual pattern that that will continue into the future. Okay, like the 2, 4, 6, 8, you correctly identified a pattern, but maybe that what we're looking at doesn't follow that pattern. Okay, now let's look at sound versus valid. So I want to talk about another definition here called sound. Okay, so we're going to look at this argument again. Premise: all frogs are green. Premise: Kermit is a frog. Conclusion: therefore Kermit is green. Okay, so we've already established that this argument is valid. Okay, so if all the premises are true, then the conclusion must be true. Okay. All right. So this is a valid argument. However, there is some funny business going on. The premise, are all frogs green? Okay, and I don't know how many of you have spent some time outside, but frogs come in lots of different colors. So are all frogs really green? No. Okay. Okay. There are many different colors of frogs. Okay. Is Kermit the Frog really a frog? Well, I mean, no, he's a frog-shaped puppet. So when I make statements about frogs, they might not apply to Kermit, right? When you talk about, okay, if a frog breathes through its skin, well, Kermit the Frog doesn't breathe, again, because he's a puppet, right? Okay, so, all right. The conclusion, is Kermit green? Yeah, he is, okay. All right, so in this example, it turns out that the premises are false, but the conclusion is still true. Okay, and that can happen in a valid argument, right? In a valid argument, the idea is that if I know that the premises are true, that guarantees the conclusion is true. If the premises turn out to be false, that doesn't tell me that the conclusion is false. Okay, it could go either way. So I could have, if an argument is valid, if I have true premises, I know for sure that the conclusion is true. If one or more of my premises is false, I might have a false conclusion or I might have a true conclusion. Right? I don't know ahead of time. Okay. It's similar with inductive, except we're not guaranteed anything. Okay. So if one or more of the premises are false, okay, then the argument doesn't tell us anything about the conclusion. Okay, so now let's get to sound, right? That was sort of reviewing valid, and now we can contrast that with sound. An argument is sound, that's what we're defining here, if it is valid and all the premises are true. Okay. So if a deductive argument is sound, okay, then the conclusion is guaranteed to be true. Okay. If an inductive argument is sound, then the conclusion is probably true. Okay. So a sound argument, when we say valid, it's very easy to get confused between valid and sound. We like to think of a valid argument as always telling us something true, but that's what a sound argument does. Okay. A valid argument is really just talking about the structure of the argument. And a sound argument is going a step further and saying, yes, all those things that you said set up nicely and work. Okay. As opposed to back here, right? This is a valid argument, but maybe it's just gibberish because it's, these premises are false. So the argument doesn't really mean anything. It's not telling us anything because the conclusion could be true or false. So it's not a good reasoning for why Kermit is green. All right. Any questions? All right, that concludes our first section. That was 45 minutes, so I think what we'll do is rather than go extra long today, maybe we'll let that be today, and tomorrow we'll go ahead and do the next section. Now,